Modern web applications move massive amounts of data in milliseconds, but that speed can instantly fracture due to microscopic formatting errors. To transmit complex binary data safely over basic text protocols, developers rely on base64 encoding. This process translates raw binary into a universally readable alphabet made up of 64 standard ASCII characters. However, the native tools developers use to create these strings often fail. The standard JavaScript BTA function consistently crashes when you attempt to process rich Unicode characters or emojis. BTA is a built-in browser method designed to encode strings of data into base64 format. Even when encoding succeeds, standard base64 outputs contain plus signs and forward slashes. These specific characters are entirely incompatible with URL get parameters. Get parameters are variables appended to the end of a web address that send data directly to a server. When you pass standard base64 through a URL, web servers read the plus sign as a blank space and interpret the forward slash as a new directory path, immediately breaking the link and corrupting your payload. To solve these formatting errors, developers often paste their strings into free online converters, which introduces a severe security vulnerability when handling sensitive data like JWT tokens or API keys. JWT tokens are standardized digital signatures used to securely verify user identity between web applications. The vast majority of these standard online converters operate by transmitting your unencrypted sensitive credentials via post requests to unknown external servers. A post request is an HTTP method used to send data from your browser to a web server for processing or storage. If that external server is compromised or maliciously logging inputs, your proprietary keys are fully exposed. Relying on these outdated browser functions or standard cloud-based converters forces a choice between deploying corrupted code, maintaining broken links, or accepting a compromised security posture. Prime Tool Hub developed the all-in-one base64 Studio Pro as a strictly offline alternative designed to bypass these exact vulnerabilities. By utilizing the HTML5 file API, the tool processes all binary data entirely within your computer's RAM. RAM is the high-speed physical memory on your local device. Because it's localized, the architecture actively blocks any external network connections or post requests during encoding. This zero upload environment is a mandatory requirement for developers who need to debug proprietary client assets or parse basic authentication headers. Basic authentication is an HTTP mechanism that transmits a user's username and password directly within the network request. True data privacy during development requires physically isolating the execution engine from the external web. To solve the mechanical limitations of native JavaScript, the tool integrates modern text encoder APIs to safely process rich Unicode emojis and complex alphabets without crashing. Text encoder APIs are modern browser interfaces that convert text strings into a stream of UTF-8 encoded bytes. For URL compatibility, a dedicated algorithm hunts for problematic plus signs and forward slashes, instantly swapping them with hyphens and underscores. It simultaneously strips away trailing equal signs, padding characters added to align encoded data, condensing the final string. When receiving data, the intelligent decoder performs the inverse function, automatically repairing incoming broken strings that are missing their necessary padding characters before processing them. Maintaining absolute data integrity across modern APIs requires dynamic, algorithmic adaptability rather than rigid, static character translation. Beyond text formatting, developers optimize front-end page loading by converting small physical image files, like SVGs or logos, directly into base64 data URIs embedded within their CSS files. Data URIs are a specific URL scheme that allows creators to embed small files directly inline in HTML or CSS documents. This chart compares a 3-byte binary block against a 4-character ASCII block. Because base64 uses 4 characters to represent 3 bytes, encoding an image causes a 33% size expansion. But avoiding the severe latency of a separate HTTP request completely outweighs this expansion. To maximize load speed without severely bloating the core HTML file, developers follow a strict threshold rule: only encode image assets that fall under 50 kilobytes. By combining offline data manipulation with strategic asset embedding, developers construct a highly secure, zero-trust workflow that maximizes front-end speed. You can upgrade your toolkit and run these conversions locally at Prime Tool Hub.